Well, good morning. This morning, we're continuing with our microbiology study, and in particular, we are in the microanatomy this morning. Yours truly, Dolphy Gilpin, coming to you from 1524 Lavista Drive, Decatur, state of Georgia, United States of America. And before we continue with the malignancies and disorders and abnormality of the body, we're going to reverse a little bit and do some anatomy, and in particular microanatomy. And we're going to be doing erythropoiesis this morning. Next, we'll do thrombopoiesis, which is the production of the thrombocytes or platelets. Hemopoiesis, which is the production of all the cells in the blood system. Lymphopoiesis, which is the specialized production of lymphocytes or white blood cell. Erythropoiesis is the production of a red blood cell from hemopoietic stem cells. And hemopoietic is stimulated in the body, circulatory system, by a reduction in the oxygen, which is detected by the kidney, and which then secretes erythropoietin. And you know the process, erythropoiesis, is the production of the red blood cells via the erythropoietic stem cells into mature red blood cells or erythrocytes. Now this erythropoiesis in all cases it starts from this hemocytobliss. Some people say, some scholars say hemocytoblast, but hemocytobliss, which is the pluripotent stem cell or multipotent stem cell, hemocytobliss. And from this, in the erythropoiesis process, now it goes to the myeloid stem cell, then it goes to a unipotent stem cell, and these cells are not really drawn to scale. This is the hemocytobliss, and this is the myeloid stem cell, and it goes to a unipotent stem cell here. Then it goes to a pro-normoblast. This is the erythropoiesis process we're talking about here. Then it goes to a erythroblast. Another name for the erythroblast is the erythrobliss is the basophilic normobliss. That's another name, the basophilic normobliss. So it goes to the basophilic normobliss. Then it goes to the polychromatophilic normobliss. Then it goes to the orthochromatic normobliss. Then it goes to the reticulocytes or erythrocytes. A shorter version of this erythropoiesis would be, I put a shorter version on this side here now. Same erythropoiesis. It goes now from the hemocytobliss, which is this, to the pro-erythrobliss, and from the pro-erythrobliss, so it goes from the hemocytobliss, which is this one, to the pro-erythrobliss, and from the pro-erythrobliss, so it goes to the polychromatic erythrobliss, and from the polychromatic erythrobliss to the erythrocytes. So this is the very short version, but the extensive and more detailed version is for erythropoiesis, which is the production of red blood cells from the hemopoietic stem cells to the mature red blood cells, would be the hemocytobliss, to the myeloid stem cell, to the unipotent stem cell, to the pro-normobliss, to the erythrobliss, or which is called basophilic normal bliss, to the polychromatic or the polychromatophilic normal bliss, and to the orthochromatic normal bliss, to the reticulocytes or erythrocytes. So that's the process of erythropoiesis. We'll next move on to the note that the erythropoiesis, just write them down here. So we'll be dealing with them one at a time. Hemopoiesis, which is like the integrand, it contains all of these other processes, which is the erythropoiesis, which is the production of red blood cells, and production of a white blood cell will be the leukopoiesis, which is the white blood cells. And in particular, we have another branch of the white blood cell, which is the lymphocytes, specialized white blood cells, which that would be lympho, lymphopoiesis. And then thrombopoiesis, or which is thrombocytopoiesis, which is the cellular version of thrombopoiesis. So we have done this one, which is erythropoiesis, which is the production of red blood cell from the hemopoietic or the erythropoietic stem cells, which is stimulated by a decrease in oxygen in the circulatory system, which is detected by the kidney, which secrete the hormone erythropoietin. So that's erythropoiesis, our process, the production of the red blood cells. So we take a break here and we come back now to either leukopoiesis or thrombopoiesis. And next, for the last, we'll use the total or the comprehensive process, which is the hemopoiesis.